This video begins with the combination of functions. First, we'll look at the domain of a function. All of the x values or values for x that can be used will be considered your domain. To find the domain of your function, you will look for the values that cannot be used. That's the easiest way to find the domain. Is to look for the values that are not a part of your domain. So the values that will make your function undefined will be the things that we will look for. So we look at this first example, find the domain of x squared minus 7x. When you think about what can you plug into this equation that will make it undefined, there will not be any values that can do this. And you see in the next example what we mean by that. When you graph this function, this graph would exist everywhere. It's a parabola. So really the domain here is going to be negative infinity to infinity because you can use any value for x. There's nothing I can plug into this function to make it undefined. All right, let's look at the next one. We have 3x plus 2 over x squared minus 2x minus 3. So whenever you have a fraction, remember whenever the denominator is 0, your fraction is undefined or your rational expression is undefined. So we want to know when is our denominator equals 0. So whenever we have a fraction or rational expression, we will set the denominator equal to 0 and then solve. So take x squared minus 2x minus 3 equals 0, set it equal to 0. Factor it, that'll be x minus 3 times x plus 1, equal to 0. Set each piece equal to 0, and that'll leave you with x equal to 3 and x equal to negative 1. So these are the values that will make your denominator equal to 0. In other words, these are values that you cannot use because they will make your function undefined. But you can use everything else. So that means my domain would be negative infinity to negative 1, negative 1 to 3, and then 3 to positive infinity. Remember the parentheses here. The parentheses here in our notation lets us know I can use everything except for the negative 1 and except for the 3. I can get as close to those values as I like. I just cannot use those values. All right, next one we have the square root of 3x plus 12. You cannot take the square root of a negative value. So my domain would be whenever my radicand or what's under my radical 0 or greater. Whenever it's positive, whenever it's 0 or positive. Anything negative, you cannot take the square root of. You can't take the square root of 0. The square root of 0 is 0. So what I would do is take the expression under the radical. I would take the radicand and set it greater than or equal to 0 and solve. So 3x plus 12 greater than or equal to 0. Subtract 12 from both sides. And 3x greater than or equal to 12, negative 12. Then divide by 3. My domain will be x is greater than or equal to negative 4. So I'll use bracket on the negative 4 because the negative 4 can be used. It will set my radicand to 0. Once again, you can take the square root of 0. So I have negative 4 to infinity, bracket on the negative 4, and you always have parentheses on your infinity sign. All right, combining your functions. Here we have just shorthand notation or symbolism for the combining of our functions. F and G are functions. F plus g of x is just f of x plus g of x. F minus g of x is just f of x minus g of x. F times g of x, f of x times g of x. And then f divided by g of x. F of x divided by g of x. All it is short notation to go ahead and apply those operations to those functions. So if I have f of x equal to 2x plus 1 and g of x equal to x squared plus x minus 2, and I wanted to find f plus g of x, I will go ahead and just add those functions together, combine my like terms. That'll be x squared plus 3x minus 1. So x squared couldn't combine with anything. 2x plus 1x is 3x. 1 plus negative 2 is negative 1. Here, f minus g of x, subtracting those functions, we have 2x plus 1 minus x squared plus x minus 2. So don't forget to subtract by first distributing the negative to each term. That'll be negative x squared, 2x minus x is 1x, and then 1 plus 2 is 3. F times g of x, I'm going to multiply these equations. 2x plus 1, x squared plus x minus 2. Distribute your 2x to each term. So 2x times x squared is 2x cubed. 2x times x is 2x squared. 2x times negative 2 is negative 4x. Distribute the 1, that's x squared, x, and negative 2. Now combining your like terms, that'll be 2x cubed, 2x squared, and x squared will be 3x squared. Negative 4x and positive x is negative 3x, and then the negative 2 on the back. F divided by g of x, all I would do is place the f of x over g of x, so that's 2x plus 1 over x squared plus x minus 2. If I could factor or simplify or do anything else with this, I would do so, but it's not necessary in this case. We just simplify as much as possible. All right, the composition of functions. We will call this fog of x. Means you would take the whole function of g of x and plug it into f. For the golf of x, take the whole function of f and plug it into g. So if I have f of x being 3x minus 4 and g of x being x squared plus 2x plus 6, and I want to find fog of x, I will take my g of x and plug it into f. So g of x is x squared plus 2x plus 6. I will plug it in where I see x. So that's 3 times x squared plus 2x plus 6 minus 4. Distribute the 3, that's 3x squared plus 6x plus 18 minus 4. Combine your like terms, 18 minus 4, so that's 3x squared plus 6x plus 14. Next one, golf of x, I'll take f of x and plug it in to g wherever I see x. So that's going to be 3x minus 4 squared plus 2 times 3x minus 4 plus 6. This 3x minus 4 squared. Don't forget to do your binomial distribution. That's 3x minus 4 times 3x minus 4, which would expand out to 9x squared minus 24x plus 16. Distribute the 2 into the next quantity. Is 2 times 3x, which is 6x. 2 times negative 4 is negative 8. And then the plus 6 in the back. Now combine your like terms. That'll be 9x squared minus 18x plus 14. All right, last one, golf of 1. So this time we have a 1 here instead of the generic x. So you can handle this one of two ways. This would be taking f of 1 and plugging it into g. So you can look at it that way. So that means plug 1 into f of x first. So doing that, that'll be 3 times 1 minus 4. 3 minus 4 is negative 1. Now f of 1 is equal to negative 1. So that's g of negative 1. Plug negative 1 into your g function. That'll be negative 1 squared plus 2 times negative 1, which is 6. Simplify, that's 1 minus 2 plus 6, which will give me 5. The other way is taking golf of x, which is 9x squared minus 18x plus 14, which is what we found in the previous example, and then plugging 1 in there. So that'll be 9 times 1 squared minus 18 times 1 plus 14. Simplify, 9 minus 18 plus 14, and that will reduce down to 5, just like what we did in the previous. All right, let me know if you have any questions.